Yeah, actually, I was looking for some good ways to structure your Go project. So while searching for the same, I came across this article. But while going through it, I'm not pretty sure that I understood the concept. So I thought that there should be a good proposal for anyone to pick up, so that anyone can um, interpret this, and if someone has understood it completely, then maybe share it with us.
Okay, I'll just share my screen and then browse to the blog, and then all of you can read and pitch in with your ideas. Are you all able to see my screen?
Yep, we can.
I've shared the link just now.
Yeah.
Yeah, Praveen, we are able to see.
Has everybody else also had a chance to look at this blog before?
No, I means I haven't looked into it. Maybe someone else can say for themselves.
Praveen, I guess you were telling that maybe you have some better understanding that, or maybe you have adopted some particular way. Maybe you can share that instead.
Sure.
That
Yeah.
what you feel is that have been comfortable for you.
Yeah. Yeah. So at least for a start, I do agree with all the three which are flawed. So the monolithic package is definitely a bad idea because you really can't bifurcate any code, and you need to import the entire package when something else depends on it. So yeah, that is anyway not good. Um, by the way, if anyone has any questions with whatever I'm saying, please feel free to interrupt me, and we can sort. I can go into more details. The rail style layout is another way of breaking things down, but I'm sure uh, like for example, if you come from Ruby on Rails background, or even if you have worked on Django and all, so basically there are there's a folder structure which is sometimes enforced by certain frameworks that you use. So, for example, when you're using that framework will tell you that you need to break folders in a certain way. You need to have your APIs here. You need to have your models here and things like that. So that's a framework enforced structure to the layout, and sometimes it becomes such a norm that people end up using it even when that framework is not being used. So yeah, so that is the second approach that is being discussed over here. It is not considered a good approach because uh, by design, when a you lose freedom in how you would like to structure things when a framework enforces its own patterns onto you, and especially if you don't use that particular framework, then using that model to structure any other project of your own is not really necessary. It becomes a maintenance problem at a later point. Breaking things down becomes a pain. So I think those things are already discussed pretty well over here.
I can just add a few more points.
Yeah.
Uh, though it is actually by convention or by practice people follow it, what I've seen is people still have separate package for handlers and separate package for models. I mean, sometimes it works out, but one example I can give is the moment we have the service, as I mentioned, like handler depends on models, and then you will have separate services package. If you want to make a change across, like let's say user, and we need to touch all the packages, and the commit also spans across multiple directories. And it's very easy for us to have a requirement that, okay, we need to pull it out as a service. An example could be is you have a lot of users and then you deal with users, and let's say authentication also you are doing it. And eventually if you have 2 more, 3 more authentication mechanisms, if you want to pull it out as a separate service itself in microservice architecture, it becomes super difficult if you have the view and handler and model kind of structure. But if we follow the other structure which we mentioned like below, it's super easy to pull it out because you would generally have authentication as a single package, and it's as easy as creating a separate directory and then pushing it. Though I'm not sure, like I've seen this still like in a lot of early code bases. Yeah.
Yeah, thanks, Anish. Yeah, I agree with that. Then again, the group by module approach is again what it's more or less similar to the Rails style. Basically, you're putting everything that belongs into a certain category under a folder, and then subfolders have more specific ones around it. This is very similar to this, except that there is no framework which is sort of enforcing it. But yeah.
So, can you hear me, Praveen?
Yeah, I can hear you.
So in the third approach, the handler, the controller, and the model is in one module in one package.
Yeah, in one package.
Okay.
So everything related to user is in one package. Everything related to something else is in some other package. Like for example, everything related to accounts is in an account package. So then there is this other. The next section has something called a better approach. So yeah, so here I mean I have not written that much amount of code that I can say that. So basically, I'll just share my idea, but I'm not sure if that is the best way. So since this is a discussion, I would just like to throw in the things that have worked for me. If you guys feel it works for you, great. So the root package is for domain types. So I disagree with this a little bit. I mean, in all my experience, I mean, whatever has worked for me is that basically you start breaking things down by a struct which you would like to reuse somewhere else, and try to break things to the smallest degree possible and put that into a package. So package should be self-containing in a way where the data that you define, for example, the structs and some behavior and the tests that go along with it, as long as that can be independently tested and independently written into a package which does not depend on other things, it should get a package of its own, and you have no restriction on creating. You can keep breaking things into more and more packages. So ideally, a good package is one which has less dependencies or tries to keep its dependency footprint minimal. So you will have packages which are obviously like leaf packages which don't depend on too many other things. So you can structure them far out in a directory structure that is most convenient to you. But any place where you combine structs from more than one package, that deserves a package of its own. So like for example, you have like 3-4 leaf packages. Like for example, if you're dealing with resources like users or something else, they each get their own package for handling the user struct and things like that. And it is possible that there is some other service which consumes from this user, which consumes from something else, and consumes from something else. It deserves its own package, so that package then imports all of these individual elements. And while doing so, because this is a separate package of its own, it can choose to either import version 1 of user or the real user or a mock of the user So any of that. So basically, you're not a package which depends on other packages is not directly depending on them in the import. Another way of putting it is like, for example, let's say you have a root package somewhere here. Alright, so let's say you have a user here, and are you able to see my screen? Is it big enough?
Yes, I can see.
So you have some service, and this service depends on, say, A, B, C, and D, right? Now A could be something like user or something. So basically, they're all resources, right? Now each of these guys has an independent standing of its own. So you can basically have a struct which defines its data, which defines its behavior, and so on. It's independently testable. It's a standalone unit. It is possible that it might not depend on many other things. And let's say there are multiple such other resources, and there is some service which needs to use all of these things. This deserves a package of its own, so that this can import these guys individually. It is possible that this service does not directly reference them, but it consumes, it accepts an interface, and then A happens to satisfy it. But it's possible that you can also have A1, which is a fake user, and you can also import this from a separate package and then inject it here. So this guy does not concretely say I depend on A. This guy does not concretely say I depend on B. It is like, for example, service 1 will import A and will import B and so on. But it is possible that in a test you can import the service 1 and make it use A1 or make it use B1 or something like that. So the more you break things down, the point where you assemble these dependencies, that's where you decide who should work with whom and so on. This gives you more freedom and less coupling. For example, service 1 should not have code which is directly tying it with user, or it shouldn't be something like user service has, like, for example, if user service was a package, and this has a sub package where the record for this, I mean the struct for this is subdirectory inside this, and then you would have a hard time moving this out of this user service folder. So basically, there is functionality inside of some other code, some other struct, which necessitates the use of a struct which is inside this, and the folder structure is what is sort of governing how things are placed. Am I able to like, was it understandable? Maybe I should ask you guys to have some more, like, if you have any questions, please ask me. I don't know if I came across fine in whatever I explained. So maybe if you have any questions, please let me know. Okay, let me. Am I audible?
Yes.
Yeah. Okay, so what I'm trying to say is you basically.
Yes, Praveen, you're audible.
Yeah. You break things down as much as possible, so that the package which is trying to stitch multiple things is a package of its own, and at the point where it tries to stitch multiple things, or where it declares its dependencies, it gets to choose what are the dependencies it should sort of consume from. And if it is in the actual application, it will be different. In the test, it will be different, and in different cases it will be different. When you make improvements, like, for example, if user was not user, let's say this was an implementation of something, right? And now you got A2, which is an improved implementation without breaking the API. You would want to just use A2 instead of A, right? You should be able to do this without having issues. Now this is more like, basically there's an API problem, but the package aspect comes in a place where you, like, because in Go, you need to have a proper tree for the import structure. You can't have circular dependencies. You need to ensure that the least dependent elements are on the leaf. I mean, and they're like they stay independent in a way where it can be imported by somebody like a dependent package at a later time. So there are going to be a bunch of packages which are going to be like leaf packages which don't depend on other packages. They have a very small footprint. They are independent. Every other package which depends on these leaf packages is a package of its own, and then that sort of imports this. And with respect to the root package, rather than putting these things in the root, it is so basically a root package could be a super minimal package whose job is to only invoke the CLI. Basically, it just stitches the application and starts it. That's about it. So every other piece of code is inside a package somewhere. The root is simply going to import from some package which is the application, and then it might have like 5 lines. Yeah. Any other anyone wants to contribute or have any questions?
One point is, I mean, when I read it, it almost looks like a model package, but in a different way. I mean, when this sort of would help is, I mean, in the next section, they talk about having a sort of like a repository layer, which again has multiple packages like Postgres or Redis, something like that. And you would want to share a model to both decode the request, and also you would want to pass in the model to repository to save it. I don't know whether you guys have done like put in the repository code also along with the same package. Like it could be user and then authentication and then multiple packages. But still, we sort of like, I mean, in my experience, we sort of tend to have a separate repository layer. And that time, managing the like, I mean, you cannot have user.user being passed to repository if you have a dependency on that also. So managing that is a little trickier. So in that case, it sort of helps to have a domain sort of package, I guess. Probably that's what they are saying. But still models, people say it's anti-pattern. I'm not sure whether like the root is meant in the same way. Yeah, you can continue with the sub packages also.
Yeah, I agreed with this point. So basically, trying to push. Yeah, this seems to make sense to me. Anyone has any questions around this? Please let me know. So ideally, like whatever I mentioned over here, right? So if you have packages which are like leaves which don't depend on other things, you push them like really far in, and you can structure them deeper, and in a folder structure which sort of logically breaks down from the macro to the more specific one. And every sub package is also an independent package in its own right. So so the import system is sort of immune to it. And it makes it fairly readable as well. Like if you have a database adapter and then you have one which is like an in-memory implementation just for testing, and then you have another adapter for some database and so on. All of these could be like independent subpackages inside a database adapter.
Praveen, also the thing is, most of I don't means I might be wrong, but most of the time, how do you structure your package mostly depends on what kind of application you are trying to build, right? If you are trying to build, I mean, sometimes in you try to do it in the what kind of means your vision also you have for that application. Are you trying to means in future, do you see it as a separated as a microservices also? In that approach, people tend to go with module system mostly, because it makes sense to have individual module deployed somewhere and without having to decoupled. Right now, means right now it's just a coupling with some in some file that can be decoupled with the future with some sort of communication, be it grpc or https. So I guess most of the time it's mostly a decision that you have to make, what kind of application and future vision you have for your application, if I'm not wrong also in this.
Yeah, that is true sometimes, but then the problem is you don't know beforehand how you're going to use it. So you at the time of writing something, you might think that I'm designing it for this purpose, but then you might find that you want to reuse some aspects of it. So ideally, if you go with an approach where you can reuse every component as much as possible, then you can easily mold it for any utility very easily. So here, yeah, you are right that we can represent all of these as a Go module and version control that and stuff like that. This has more got to do with the uh, inside of like what should constitute a package, and it's maybe one level lower, but yeah, the problem at this layer is that we don't want multiple packages to sort of couple with each other in a strong way. Second thing is, if there is a third package which is depending on some other package, then we don't want it to import things which are not required for its own use. Another thing is, the more discrete your packages are, the better the API can be in terms of what you consider private and what you consider public. And the so when you make these packages smaller, then you are forced to define a more clear API. You are forced to think about dependencies in a more clear way, and that'll that'll lead to like APIs which you can work around with. For example, you can easily replace parts without having to touch several other files at the same time.
Yeah, I believe means a sort of the core is becomes your entities, whatever is the core business logic is, right? And with the use case, and then on the top of that, layered approach also.
Yeah. I mean, here actually we are not going too much into the what the application does either. Like for example, a lot of examples here are tend to be like a CRUD service around some database and so on. Mostly very common in microservice related architectures. But if you're writing even like a simple CLI tool or some tool which you want. I'm trying to like look at this problem in the most generic sense possible. Like what is the most abstract solution to structuring packages? And the thing that has helped me most is when I try to make packages really really small and clearly identify the packages which have no other dependencies on them, and they are like the leaf packages, and then you put them separately, and then the part where you pick these packages and then you integrate them into something else, that is a separate package by itself, and that is like implementation one. And there can be another implementation which again picks up some more parts and then assembles them and so on. And these packages need to be just as small as possible. They have like a very very well defined goal on what they serve, and they have their own tests. They have a very distinct API, and they only so the smaller its footprint, the better. And that gives you more flexibility in replacing it with a better implementation and things like that at a later point. The best I design for me is one where I can still make changes. Like I know I might be wrong halfway through my implementation, and I might like even if I completely change the directory structure to suit something else, it should not require me to make far too many changes, or I shouldn't get to a point where I have to live with whatever I've written, right? So like if you want to use that as a premise, then it is easier to ensure that you make really small discrete packages. How you place them, where you place them, will get determined more or less when you start importing into other packages, because you can't do circular dependency, so you'll be forced to break things into things which are completely independent and things which are sort of dependent on those independent things.
Okay.
And in many programs, I have seen the main or the root package being almost like super minimal. And I see an advantage in that, which is that you can almost reuse every damn thing of the package. Every single piece of code from the package other than the main can be like reused for testing or for reused in some other context. Like your entire application is like which 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 can become a sub application in a bigger application if you choose it to be. So the main package is just the one that sort of binds everything together. It simply imports and that's what you use to build the binding. Other than that, it doesn't have any core functionality of its own. Any other questions? Anyone would like to contribute with their ideas of what has worked, what has not worked?
I can just add an example in this subpackages if you guys want.
Yeah, go ahead.
Should I post the code here? Okay.
Should I share? Should I stop sharing? Would you like to
Sure.
share?
Sure. Do you want me to share it? Like in that case, you won't have to stop.
Yeah, Dinesh, I have opened your link. That's the one you shared, right?
No, so probably you can talk about. I'll ping in this place. With respect, to, I mean, I'm pinged in chat.
Okay.
So probably you can paste it. So this subpackage is really helpful in case of repository kind of style I was talking about. Yeah. Can you just paste this? Yeah. I'll just edit this, I guess.
Hey, do you mind if I stop sharing my desktop? Maybe you can share yours.
Oh, sure. Yeah, probably I can. Yeah, give my experience also. Sure. Can you guys see the screen?
Yeah.
Okay. So with respect to subpackage, though it sounds like, I mean, it is very independent package, that is agreeable. But the thing is, it's good to have a contract and then the subpackage actually ties to the contract. So what I mean by that is, let's say we have a repository and then in the top level, we would have something like a repository profile. And in that, we can have an interface which actually, like on a high level, has a save functionality and fetch functionality, right? And you can have, as he said, like internal either in-mem or Postgres or Redis. But what each package would ensure is everybody actually returns the stores interface actually. Like this particular interface, everybody have to other to this package. So it's sort of like we've used it in a lot of places. So which means each and every subpackage depends on the parent store, and then everybody implements their own implementation of the interface. So which means on a high level, let's say some login or anybody, they can use store.store interface. I mean, ignore the naming, that is a wrong name. But in this case, you can at runtime based on configurations or anything, you can either inject a Postgres or Redis or in memory. And also it helps in case of testing also, because you can sort of have a table driven test if you guys used it. So you will be writing tests only for save, but you will have all the implementations in the setup. So which means you will ensure everybody works as expected using table test also. So it also helps in that sense. Does this point make sense?
So basically, at the top level, all you need is now a factory, right, to create.
I mean, no, not factory. Like we wouldn't have factory in repository layer, but rather in a different package, like a server or something, right? There you will say, hey, login, new, this guy will need a store, right? So this guy will need a store. But here you can give Postgres new store, something like that, or some other store based on the configurations.
Okay, got it.
At the inject time, you will do it, because here you cannot have factory, because all the subpackages depend on the store, and store cannot depend on the subpackages. So it will be cyclic.
Okay.
So this sort of like will go from based on configuration. You can choose whichever you want. And probably on the same line, I can add one more is, let's say during login, right? Login mostly, let's say you are only fetching, you're not storing anything. Probably sign up would do a save, right?
Yeah.
So in that case, you wouldn't actually directly depend on store interface, which is implementing both save and fetch, but rather what you would have is something like a fetcher .go, which actually defines the interface saying fetcher interface, and then here you will have fetch only fetch, and you will have to, I mean, you can use anybody who's implementing this, which means obviously store is replaceable. But if you think of testing, and then if you want to mock it, you don't necessarily need to mock save method, and then all you need to have is a mock which implements only fetch. So what I mean by that is in login, eventually you will have something like fetch user. If you're using only that particular method out of the 10 methods in interface, which is a smell, use only that and then define an interface for that as a package. So which means you wouldn't have login depending on store, but rather you have a interface and then anybody can inject it. Only the main package which is injecting everything will depend on all the packages, and login wouldn't depend on stores. Like, does this point also make sense?
Okay. So my only question is, if I have to change the fetch method,
Right.
this fetcher interface is also defining the fetch method. So any changes I have to do inside the store interface or any of the in-mem, it has to be brought up till fetcher, right?
Correct. Yes. I mean, if you're directly using store interface, you would still have to rename wherever it's being used. But the best part here is you're actually removing the dependency. So in that case, let's say you would ideally want to pass in user, right? So let's say login.user. This guy takes login.user. You cannot have this store depending on login if login directly depends on store. So mostly this would be the case.
Okay.
And save would be like, let's say authentication.user, right? And if you depend on store, you cannot have this model as parameter.
Okay.
So, and it's not just for repositories. It's like, there are cases where you're using a client which defines like 1 to 10 implementations, but rather if you need only one thing out of it, If you have a custom interface, you can mock it easily. If not, you would have to define a mock for the all implementations, which is again a pain. So that is why, I would generally prefer this, which is super awesome. I've seen it helping in a lot of cases. So what I mean by that is all the packages wouldn't depend on other packages. Mostly it will have its own interface. And then people will inject it. So whenever you want to have a new login service, you would have to have a constructor, and then you would ideally pass all its dependencies in the constructor, something like that. And which by this actually you are making login not depend on other packages. All you would have to do is server will depend on repository, server will depend on login, server will depend on authentication. This guy is the one which actually ties up all the pieces together and then brings up your service, and not other way around. So this is one thing I was about to tell. So probably one more thing is middleware. I've seen, I'll just finish it up. You can continue the blog also. So CMD, I think pretty much people would have used it. CMD is the one which contains multiple subpackages, and I've also seen it very helpful. Like you have server and you will have migrate, which is a tool like you can just run migrations locally, and then any other CMDs, like anything. Each and every subpackages in the CMD itself will have a binary on its own, and it's meant for different purposes. I think pretty much a lot of people use it. Store I've mentioned, and middlewares I've seen generally being a separate package, and you use different middlewares as per your need. And apart from that, all the APIs, right? Like let's say create user, create, save user, fetch user. All of this would go under a user package. This I've seen also. So each of them will have its own services and functionalities, but repository being built out. This is one thing I've seen in a lot of cases. And I just wanted to add one more point with respect to the blog, which actually mentions use a single package for mock, which I actually disagree, because it is useful in case of you're using very complicated external clients. Let's say you're using GCP, or you're using Azure to deploy something, or you're using some really complicated service. Within an interface, you have really 10 methods. Then it makes sense to have a mock for it. If you are using any other external client, right? So let's say in this case, we are using, let's say, some, what do you call that? Let's say GCP, a new instance. You want to create a new instances. In this case, you would ideally want to depend on the external mock, because they would keep the mock up to date with the actual implementation. So if you have external libraries, it's okay to use their own mocks, but I would still prefer having mocks for each and every interface in the same package. It's still okay to copy paste it if you need it, but rather what I've seen the cases is I don't really need a full-fledged mock with actual mock libraries, but rather, let's say in case of login, right? In Fetcher, I always will have a failure, so I can define a failure, something like a failure fetcher, and then all I can say is return error within this. So in this case, I don't really need a complicated mock, but rather I can define simple implementations. And I've also seen cases where in middlewares, right, all I need is something like whether you are actually calling the next package. So it could be something like you define a server or a handler func. Within that, you are tweaking a global variable or some custom variable you are being passed. And then this itself is mostly sufficient, rather than you creating a mock for a HTTP server, or creating a handler func which has complicated things for all the parameters. So I still think, depending on the packages, whatever is your need, you can actually mock whatever you're only using it. So which means you can tweak it as per the need, rather than having a single bloated mock package. That was one thing I remembered and wanted to add. And also, you guys can look at the link I've shared. Okay, I think I've shared only Magnum. Sorry, do you guys have any questions here?
Dinesh, can you talk a bit more about the different binaries that you have created in the CMD? Because actually I haven't used it, so if you can talk a bit about it, should be really good.
Okay, cool. So this is basically any backend API service. This is the most of the cases. What is the two use cases? One is to start your service, right? Generally, Rails serve or something like that is the equivalent, right? So for this starting the server, what you would need is you will have to do some server, and then you will have to pass in some flags. This is basically starting your actual service, right? This is straightforward. Probably you would have had created a main in the main itself, like people have done it. But let's say the moment you're talking about any service, which also has a database, right? What you would need to do is we need to have migrations in the package, and then you need to run migrations. So which means we generally have migrations, and then this will have create table up SQL, and then create table down SQLs. So these are normal migrations which you have seen, right? So for these kind of things to run, where will you run it, right? So one approach could be is you can say dot server start, and then you can say dot server migrate. Based on flags, you can do whatever you want. But if you think of it, asking a server to migrate wouldn't make sense. And also, it could be something like dot server cleanup, which is really not the functionality of a server, but rather a server functionality is starting and stopping, right? Majorly that. So what we would generally have is under CMD package, you will have a start functionality and stop functionality, which is basically a single binary handling both start and stop. Within migrate, what you will have is generally you use mattis migrate, and then you have something like rollback or up migrate. And within local, you could have something like clean temp files or drop, huge database or something like Docker up. It could be anything which is local to your case. So, but I've seen mostly server being used and migrate being used, because you also cannot have the migration files inside the server. Generally, you will run migrations as part of CI. So you will generally have only migration files, which is SQL files, and the configuration for your database. But still, you would have to have this kind of separate utility. Probably one more example could be, let's say you're using any command line utility, right? Some FZF tool or something like that, or probably to let's say LS, right? Some listing, purely listing. You can have multiple packages to have a different kind of implementations also. That is also possible. So it's like here you can have a gRPC server in the similar way. And this will be HTTP server, something like that. I mean, I'm just giving an example, naive example for this, but you kind of have different command lines based on your need, and then you use it accordingly. Because the flags is a way to control the logical flow and then define it, but still you would generally create a separate utility for its own. So that's the command package generally suggested. And then it's also available in the actual Golang documentation.
Okay.
Yeah. So I mean that's around it. Like yeah, that's all I had. You can actually continue to Praveen. I'll stop sharing.
Yeah, just a minute. Just before you stop sharing.
Yeah.
So could you scroll up a little?
Yeah.
Yeah. So in your fetcher in your login folder, there's fetcher interface, right? And below there's the user also. So in this scenario, would you suggest putting a mock implementation as one of the sub implementations, uh, which uh, which again obeys the interface?
Sorry. So in case of here, where would I keep the mock?
Um, Maybe could you scroll down a little? There are a few implementations. Right. Okay. So the store has in-memory Postgres and Redis. These are like concrete implementations, right? These are maybe adapters to talk to each of these services.
Yeah.
So at this layer, like for example, in mem, right? Maybe at the same layer, like you could, would you say you would have another mock store,
Huh.
which is a folder in itself at the same, which is a sibling to in-mem Postgres Redis,
Mhm.
and that is like a mock implementation for the store interface, and it obeys the store interface as well.
Right. So, I mean, if you think of it here, like I would generally keep a mock. I mean, this store almost becomes like a concrete implementation. If it has more than 2-3 methods, then obviously I would have a mock here, not a separate package, but rather wherever the interface lies in. So in this case, I would have a mock because it doesn't matter. The mock is common for all the packages, right? Because everybody is adhering to the store. But this is the usual flow. What I meant is, let's say you're having a authentication package, right? In this case, mostly all I want is fetcher. And if you're really bothered about like only failure scenarios, I mean, this is a naive example, but like not necessarily for store, but let's say for some other service dependency or some other package dependency, right? So I would have the mock here for the interface which I have here. So here I will have a interface fetcher, right? For this fetcher, I would have a fetcher mock here itself. Because I don't really need to have a complicated mock, but rather I can just pass a nil or error in this case. I just mentioned it because the moment we have bloated mocks, I mean, it's helpful, but this is much better because you don't need to worry about the actual client and the mock updations.
Okay, so my question was slightly different. Like for
Okay.
example, let's say there is something else which depends on the store. So it is
Sure.
basically going to import store slash Postgres slash. It's going to import from store Postgres, and then you create a new, and then that returns a store.store.
Correct.
Right? Now, let's say for a test, I don't want to work with the Postgres database, so I would rather work with a mock. Let's say, for example, right?
Yep.
So in
Perfect.
such a case, I will still import from say a mock package, like for example store slash mock, and it will have a mock implementation. And every other API is exactly the same. The difference is what I import from.
Right.
So is that already the case in the rest of the folders? Like for example, in-mem, Postgres, and the other folders, right? The Redis, right?
Yeah.
They all have almost mimicking API, right? They have the exact API that
Correct.
they have a shared API. So basically, you replace Postgres with Redis, and then you start working with Redis. It's almost like that, right? It's like plug and play.
Yeah.
So in such a scenario, like have you come across examples where there's a mock at the same layer where the mock implementation does basically nothing, but it provides the whole API. It satisfies all the interfaces, but it does nothing.
Okay, just to clarify, are you saying you would need mock on each and every subpackages, or are you talking about mock on the store level with a single thing?
I'm saying a mock implementation as a sub package inside store,
Oh,
which is similar to in-mem Postgres and Redis, except it does nothing, but it satisfies the interface and it returns the store and things like that.
but okay, but why would I need a separate package for it, like store mock?
Ideally, you would like let's say there is a different service which depends on store, right? And at the point of and let's say you're trying to test that, and that depends on store. Rather than making that service depend on some concrete implementation of store, you could make it depend on a mock of store, and it's a plug and play replacement of not doing anything.
But if you think of it, the mock should also adhere to the same store, right? So if I get it right, so you're saying I could have a mock package, so I can have a mock store here, and then log it can actually depend on mock store in test. So I'm gonna say this. I'm gonna say something like this is what you're saying, right?
Yeah. I'm no, not really. Like for example, this mock store could it be inside the store subfolder?
Right.
It is no different from any other implementation.
Okay.
And
So I think that's just a choice. Like, I mean, both of us are saying, like, obviously people would depend on store. So I wouldn't mind keeping it in the mock package if you're being explicit. But I've generally used mock.go files, and then wherever the actual implementation is, the mock is also in the same place. So I can actually have store.mock store. Like, I can expect the mock in the same package wherever it is. But I think it doesn't, like, it's not a lot of difference. One more minor point I would say is if you have a test data and then if you don't want the mocks to be packaged, then it helps to have the mock in the same place, like same package as it is. So in this case, your mocks wouldn't be shipped as part of the binary. But if you're having a mock package and then if you're keeping in part of a store, that's actually shipped inside it, right? So if you're to optimize, if you want to optimize a lot, in that case, I'm talking about.
Yeah, I get it.
Yeah. So otherwise, I think it's not a big deal whether you have it as a mock package or mock file. I think both are fine. Yeah. If there's no other questions, I can stop sharing and then you can continue. Probably I can look at this other package. The other link I've shared, that also has an interesting, lot of good links. Just a second. Yeah, so I can stop sharing. You can carry on. Cool. Copy.
Hey, yeah, sorry, my Zoom disappeared a little. I was not able to unmute. Okay, so the things that are left in that blog, it also talks about dependency injection. So I've used dependency injection in Python, and it's really it's useful in dynamic languages when you have a very large application. I have not seen it being used in Go. I am not even sure it's very suitable for Go, because it's compiled and you're doing imports ahead of time, and you're building a binary with all your dependencies packaged inside it. So the advantage of doing dependency injection in a lazy way, like all these Spring frameworks and other things, what they do is they will import a certain package at the time of first use. So you have a way of declaring all your dependencies beforehand, and then you start your application, and then as your application starts depending on other things, at that point it will lazily load whatever is required and instantiate instances of that class and so on. But this requires a facility. Like for example, in dynamic languages, you have the facility of doing an import whenever you want. You can place an import wherever you want in the code and import it lazily. That is one aspect. In circular dependencies, it's sort of indirectly you're doing imports at some point, and it's all done during runtime. Whereas in Go, you don't do any of that. So there's a big difference in how the packages themselves are built and how the dependencies are, how the imports are basically structured and so on. So that's a core difference there. I remember reading about one dependency injection package in Go, which basically you declare your dependencies and you probably trim it down, and it picks out those ones to include in your binary. But I can't recollect it now. I don't even remember if it was a blog post or whether there's actually a package which does it. I'm trying to look for it, but maybe I'll search it and post a link in the issue. But yeah, dependency injection, I really don't think it is that great an idea for Go. If you read up on there's a blog entries on GoKit, which is a package to allow you to integrate other services easily and build a microservice in an easy way. And there's a blog entry by the guy who wrote GoKit, who is Peter Borgen. So he explains some of the aspects of how it is actually easier to tie in all the dependencies and write a large main function and just um, instantiate all instances and then all dependencies, and then you structure it in a way where you put in the deepest dependencies first, and then everything else that depends on it starts calling that later on, and then you sort of build the main in a way which is forward, where dependencies are instantiated first, and then those things which depend on it are written. I mean, everything is written in form of code, and you have a large main function. So that is one approach which has been suggested by Peter, and so far I've seen a lot of programs which sort of do that, and I have not seen too many programs written in Go which try to do something different based on the way they are invoked. Like Dinesh was showing an example of a CLI tool which has subcommands, and each of these subcommands does something different. One of them would be like starting the server, and the reason for having these subcommands is that like it is possible that most of these subcommands share similar code and they all live in the same repository. It's just that you're invoking the command to perform a different role, but it is possible that it is using a lot of shared code already. But so while that is there, it's a standalone package, but the places where dependency injection is used, it is really, I mean, we are talking of really large packages where you're only invoking things which are needed depending on when they actually get used in the application. Has anyone had any experience working on Spring or any of the dependency injection frameworks?
Okay, sorry. So, I mean, I'll come back to the point of Spring, but I think just to clarify or probably add my sense to it. So here, dependency, they don't mean dependency injection as such, but rather it's a package who decides what sort of implementation goes into the what do you call that, like the actual code. So to be precise, here probably we can have like API which has a logging, and then here we can have logout, something like that, and probably something like user something. And then if this guy needs service, dependency is nothing but like you're actually telling what is needed for this particular object, right? It's not necessarily by annotations, which is sort of shown in other languages. So in this case, even you can have a handler func or a handler func. Generally, you would want a handler func, but you would want to wrap it inside some service, right? So the server or generally the main package, which actually do something like handle func. Here you need to have this, let's call this login handler, something like that. So here you will have to pass login handler, but for login handler, you would have to pass some service, and this service could be from any package. And also when creating a service, you would need some, let's say, store, and this store could be actual implementation from Postgres or Redis or in memory, right? So this guy is actually deciding what sort of actual concrete implementation goes into each and every interface of the callers. So which means service, I decide what to go inside store, and then handler, I decide what is going inside the closure. So which means basically this server will have a dependency on store, I will have a dependency on Postgres, I will have a dependency on handlers, middlewares, everything. So I think it's sort of stitched, but still this is a dependency injection if you think of it. I have never used dependency injection libraries, but personally I think probably this is what they mean by injection with respect to with context to this. Did I make sense?
Yeah, I also agree that so this hand-stitched way of dependency management is the right way to do it. You're creating the dependencies and you're rejecting it into those guys. This as opposed to a framework which does it for you.
Yeah. Yeah. So here also they're saying the main package is what gets to choose which dependencies you're injecting to which objects. Yeah. So it all depends on all implementations. That's it. Sorry. Any questions here? I can also answer. Okay. So I thought like probably I'll quickly tell 2 points here, like which I found. I think CMD I've shown already. So package I've seen in a lot of open source libraries, which is actually like they need some functionalities, but rather they check in into package, and it's sort of a feature kind of thing. Like it could be a store or implementation, or it could be some what do you call that? Like it's something which is exposed by libraries. I've seen people checking in, and also vendor mostly. I think we're using dependency management tools, but it's also possible that you want to have some custom code along with your dependency. So I've seen some open source libraries actually checking in vendor also. So that is another thing I've seen. And config package. Config package I've used pretty much because generally we load configuration to structs using some YAML library or env config, which is from Kelsey Hightower, which is really nice. I like it. So the config will have sort of a singleton configurations, like config.service, which holds like probably I can type. So generally I've had configuration package, which again has a DB. So in this case, you are actually reading from it, but you are actually telling host, port, and then SSL enabled, all these kind of things. And then you can actually generate DB URL from it. And then you can give a string. This kind of thing is possible. And also you can have a service, which again says which port to run and stuff like that. And also something like toggle features, whatever. So all this structs, which actually is used in other places, I've actually exposed it via config package itself. So you can say something like auth, something like auth enable. We can have the package directly expose the function here, and then you can use the toggle features and then return the value here. And then you actually load it using some library, but something like auth enable. This sort of helps because you load the application only once, and the configuration you don't have to inject it any place, because anywhere if you need anything, you just call auth enabled and then you do things appropriately, something like this. So this I've seen. I mean, personally, I've used this a lot also. So that is a really nice thing. Any questions here with config package? Okay, I'll move on. So other thing I've seen is scripts is really nice, because these days we are Dockerizing the applications, and also we have makefile, and then we will have a lot of shell scripts. So that personally, I think scripts is being useful. I don't know about the init scripts and all. I've personally never used it. So scripts, any shell scripts which you're using, we can put it here. That's why I don't know why it's needed. Yeah, docs, if you're having Swagger or some kind of documentation, yeah, I've seen this kind of package as well. And yeah, so this sort of has a nice structure. I think they probably have a example as well. But personally, I find CMD configs and API scripts. Yeah, those sort of like we've also used it, and it also helps.
Dinesh, could you please explain about package PKG? You explained a bit earlier.
Okay, let me go here.
PKG one.
Okay. So this is like one is we build libraries, client libraries, like let's say authentication or some sort of service, and then that library is purely meant for reusing. But in case of some service where you've got a nice feature, you've not even exposed it as a separate client library, but rather it is inside the package. That's how I can put it. So it's something, a nice feature. People can actually import your whole library, and then whatever in the package, they can use it. So probably I can say it's not in a state where it's being pulled out or they don't want to set up a separate CI for this feature, but rather still it's a nice feature. They can put it inside the your code, and then in package it's sort of functionality used by other code. That's it. Any example? Does that make sense?
Yeah, sort of.
Hey Gaurav, this PKG. So basically, in the Go path, you'll also have a folder called /PKG, right? But that's a place to put compiled libraries. I mean, binaries built as libraries meant to be used by other packages, but where the source is not open.
Yeah.
Is this a PKG which is meant to serve the same purpose? Like the text seems to hint in that direction, though.
Yeah, I think so. I've not used it, but yeah, you're right. Like, yeah, that sounds exactly the same.
That is okay to be used by external applications. So basically, other applications will sort of will import from this package, and basically what they import is a compiled. I mean, they import a library as a library, not as a source which is imported. I mean, they link to a library, right? Right off.
Yeah, yeah. So you could even stitch together multiple libraries and then put the output here, something like that. Yeah, anything would work. Not exactly your source code, but anything which is used by other callers.
Okay.
Yeah. I mean, that's what I've used, but I think you guys can go through this. This has really nice structure. Yeah, people say source, we should not have it, obviously. And models also, I've read in a lot of cases where it's anti-pattern. You shouldn't have a models and then everybody depending on that. That's to watch out, I guess. And also, obviously, handler view and model separately. That like a Rails package organizing by type rather than functionality is something which people say not idiomatic. Yeah, you can take over. I'll stop sharing.
I think we are open to questions. We are already beyond time, so if any of you have any questions, please let us know.
Ganesh asked why models is an anti-pattern. You can show. Praveen, you want to answer?
Yeah, specifically the anti-pattern comes as an aspect of framework enforcing certain ideas. So there are frameworks which expect you to structure your code in a certain way, and in case you are using, like, I think even Go has some web framework which follows this kind of a model. I think it was I don't remember, but it's like a Ruby on Rails implementation which is in Go. I mean, similar to that, but in Go. All of these, they tend to have prefixed folders for where you should put certain pieces of code. as long as the application tends to adhere to only that, uh, folder structure works fine. But the moment you try to reuse that piece of code for something else, or if you would like the code that you've written to be reused for any other application outside of what you've written for, that folder structure does not seem to fit other needs well. So it is written with the framework expects certain things in a certain place because it is designed that way. But that sort of principle need not be used everywhere else blindly. And it's an anti-pattern largely because you sort of put all your models in one place and everything else that depends on it goes in some other place. And the moment you change one aspect of this, every place which depends on this also needs an update and so on. There may be frameworks which, I mean, when you use it in the framework context, maybe the framework takes care of a few things for you and things like that. I mean, there are things which the framework requires that you use it, and you're probably using the framework largely for that purpose. But using the same thing everywhere is not a good idea, because you probably don't need it. Is the first thing, and you'll need to update far more things and make changes outside of you need to make changes in multiple places. It's not good from a maintenance perspective. The answer that I've given is very generic, but it ultimately boils down to how you use it and how you maintain these pieces of code. The anti-pattern comes from the fact that frameworks tend to enforce certain folder structures which need not be used elsewhere.
I think Go Buffalo framework makes that model, if I'm not wrong.
Yeah. I think that's
yeah. That is where Ruby and Rails it's basically implemented that way, I guess.
So I have never used frameworks, but I think still I can give one example. Let's say we have user name and then age and then let's say some other property, let's say gender. You will have you will be using this in two places. One is in JSON parsing, and the other place you will be using in DB saving. And then what we generally have is this is like you can say something like JSON username, and then you will have something like DB username. But the moment you start having, let's say, created at, which is needed in database, but you don't want to expose it in the APIs, right? Then it becomes tricky. Or let's say you have something like token, and in login case, token makes sense. But the moment you're actually fetching users, creating a getting token out of a user doesn't make sense. And in this case, probably what people might do is, I mean, not the right name, but you will have something like a minimal user, which will have a name and then which will again have a age and gender, which is sort of weird. Because ideally, if you think of it, if you are reusing a model, but because of the requirements, you tend to have a different structs. I mean, you're forced to have a different structs. You don't have a choice. So what then you can do is in login, you can have an actual user with token. But let's say in get users, you don't really need to have a user with token, but rather you will have only name and age. And database can have its own struct, and then people can build it and use it. The moment you reuse it, it becomes trickier because I've seen a lot of cases where in one case you need a field, in other case you don't need a field, and we sort of tend to have created multiple things. This was the case very earlier. So this is also another reason why you can say it's anti-pattern.